Hello again. It's 10:45, and I think we can start with rest of people will join us during the event, as it's always on big technical conferences. Let me introduce myself. My name is Grigory. I am technology evangelist at Voximplant. We are a cloud communications company, and today I want to tell a story about magic that is behind video calls in modern web browsers such as Microsoft Edge. The keynote, it was really amazing with all this language history, and I also think that history is a very important piece of information that we need while using modern technology and embracing the future. So I will start with a bit of history. This story of magic and video calls, it started in the year 2009. A group of software engineers from Google, they was in search of gaps between web browsers and desktop application. They was figuring out what desktop application can do that browsers can't do. And they found out the last major challenges of the web. They called it video calls, audio calls, and real-time data. Because at that time, this functionality was provided by Adobe solutions, like famous Adobe Flash and less so famous Adobe Air. It's like Flash, but for mobile devices to embed into applications like Android and so on. Flash was actually good, but with its own shortcomings, especially it was a plugin. So if at that day we wanted to provide users with something like Skype for web, they needed a plugin. Install it, accept it, and most importantly, Flash plugin was outside of web browser developers' reach. It was provided by Adobe, maintained by Adobe, and bugs and security flaws for years. So developers, Chrome developers, Firefox developers, they really wanted to replace Flash with something native to web browsers. Because you see, if you use Flash for real-time communications and you roll into production, at year 2009, that requires media servers to send gigabyte and terabytes of audio and video data. And such media service, they was simply expensive. So, in the summer of 2010, at big international event, Google created an informal lunch, and during the lunch they invited lots of companies themselves, Microsoft, Apple, Mozilla, Skype, Ericsson, and others. So they eat, of course it was lunch, and they discussed real-time communications, how web browsers can be used to send video, audio, data in real time without Flash. And a new technology standard was born named WebRTC. RTC part is for real-time communications, of course. The WebRTC technology, it had one goal: to replace Adobe Flash and Adobe Air for both web browsers, desktop, and mobile. But what is technology standard, WebRTC? It's named technology standard. Actually, it's umbrella term for lots and lots of different things. And then someone speaks WebRTC name, it's really lots of different things. Namely, first of all, it's network connectivity, and WebRTC, it's all about peer-to-peer connectivity with not traversal feature. Developers, they remembered that Adobe Flash and Adobe Air and dread a expensive media service. So idea was, if I want to do a video call from this laptop to that desktop, let's hope it's a desktop, not just a monitor system, they should connect each other in peer-to-peer mode, so we will not need an expensive media servers, and all this quality video information, gigabyte of it, will flow between devices. That was idea of network in WebRTC, and of course, if this laptop is connected to speaker's Wi-Fi and mobile phone or another laptop connected to non-speaker's Wi-Fi, they have different IP addresses. They supposedly can't connect each other, but WebRTC should be able to connect each other by tricking NAT hardware with advanced NAT penetration techniques. Second, WebRTC is about capture, send over network, and playback video, audio, and any data. And you see, WebRTC, it is much more. It's not only capturing video or audio from camera, microphone, not only sending and playing. It's in control. It analyzes network condition, like is it good network, is it bad network, is it like, oops, ping goes down and up. So it controls bitrate, it selects best codecs, it can even change resolution of video in real time. So if we are on the fat network connection, we can experience like Full HD video. And if we are on mobile phone with some cell weak signal, we can see our colleague with less resolution and less data usage. And about audio, about phone calls. Phone calls, they are different. You can hear me right now clearly because we use lots of technology, all these expensive boxes, hardware, speakers. They are doing really lots of work right now under the hood. So it is noise cancellation, echo suppression, and lots of different things. And if you do a voice call through a laptop, for example, laptop microphone and hardware, it's not very good with these things. So WebRTC also was rigged up, so it can do noise suppression, echo cancellation, and provide clear audio while doing calls. And of course, video and audio, they are good, but right now in year 2017, it's Internet of Things, but it was predicted 8 years ago, and WebRTC is also about real-time data. Data from sensors, data from virtual reality controls, any data, and developers can select do they want UDP-style real-time data, or they want TCP-style data that is guaranteed to be delivered. And there are goodies. WebRTC is really big thing. It provides screen sharing using web browser, so if you are implementing Skype for web, you can enable your users to click a button in the web browser and send a complete screen as a video stream to remote end, or just share one application. And in-browser recording, so all these video, audio calls can be recorded inside browser and, for example, sent to Microsoft Azure Cloud for later. That sounds good, very good, and it was all 8 years ago. But in reality, WebRTC is a working draft. 8 years ago, developers started to plan how WebRTC should look, and these plans, they are on official WebRTC website WebRTC, and it's still evolving. It evolves every day. We are working with WebRTC since it was created, and each few years it provides us with a big surprise. I will tell a bit later what kind of surprises are they. But it's still marked as experimental technology on lots of websites. So, year 2009, it was created, drafted, and how it arrived to end users. Actually, it took 3 years for web browser developers who originally invented WebRTC to place all these technologies inside web browsers. First implementation was in Firefox 22 for desktop and 24 for Android, and a bit later Chrome 29 with both desktop and Android implementation. First, WebRTC was very simple. It provided video calls with Google VP8 codec. It's a free open video codec, Google own competitor to proprietary H.264, and Opus codec for audio. It's good codec. Second one, G.711, it's codec from Telecom. It's legacy Telecom codec that can compress audio only 2 times. Not MP3, and it was implemented so you can out of the box call from browser to hardware SIP phones, for example, or you can call into cell network without any re-encoding. And both Chrome and Firefox, they was created, WebRTC implementation was created based on free open library from Google. It's called libWebRTC. With Firefox it's tricky because they only took network part and codecs part from WebRTC with all JavaScript API and all logic created by themselves. So during the year 2014, it was a peaceful evolution. Media stream recoding was added into Firefox 25 and H.264 video codec in Firefox 33. But at the end of year 2014, it was a big surprise from working group. And when I talk about surprise, you see working group that actually write specification for WebRTC. They are not some separate engineers who work in vacuum and never contact outside the world. No, they are actual developers from Google, from Microsoft, from Apple, from Mozilla, who exchange letters via mailing list, who often join at conference, who talk, but they need to make some decision that will be good for everyone. Yes, and one company better likes one technological approach, another company like different approach, and after some time conclusion can be a surprise. Yes, and it was such a surprise where good callback-based API was replaced with completely new promise-based API. Because you see, it's year 2015 approaching, it's that year 6 promises, async, await, all the goodies on the horizon, and it was replaced. So the browsers, the developers should implement all these new API. It was first implemented in Firefox 37 and 38. Chrome lag behind a bit with only recoding implemented in 47. And after that, at the beginning of 2016, it was 1.5 years ago, recent history. It was a second working draft surprise, and that surprise was bigger much bigger. They completely changed the API related to how media streams are organized. And I want to talk a bit about that because it's really important change. First versions of WebRTC, they was all about calls, audio calls and video calls. And what is video call? It's two streams that are synchronized. It's video and audio. So the API, it was all about streams, like I capture camera and microphone, add stream to WebRTC, and both audio and video peacefully travels over network. All is fine. But at the beginning of year 2016, developers, they needed more, much more. They wanted to add screen sharing, for example, to existing connection. They wanted to send multiple video streams with different quality. So legacy stream-based API was not enough. And working group, they like, okay, we will change it completely. Now stream-based API is deprecated, and that's new shining track-based API. You should implement it in web browsers, and developers now, they can add video track from camera, add video track from screen sharing, add third video track from Canvas, for example, and all these three tracks should be sent over one connection. Of course, WebRTC, it can initiate multiple connections, but as I already told, each connection is kind of not traversal, it's slow in to investigate network. So some web browsers, they really wanted for developers to use one connection, so no slowdown. And during years of 2016 and 2017, web browser vendors, they was trying hard to actually implement all these things. Traditionally, Firefox was first with version 45. They implemented a track-based API, and Chrome, somehow they implemented just VP9 video codec. It was an evolution of VP8 video codec. Still in version 50, recent Chrome update, they at last implemented H.264 video codec. So at that time, Chrome and Firefox, they can select from two video codecs. They can use VP8 or they can use H.264. But of course, it was not about web browsers. It was about compatibility with other devices, because with WebRTC, you can send video and audio to mobile device or to hardware phone, and hardware phones, yes, they can play video, and they don't know about VP8 from Google, but they do know about H.264, and that was a great compatibility layer. And finally, promise-based API landed in Chrome 52 and 53 version, followed by screen sharing capability in Firefox 52. That was all good, all evolution, and WebRTC flourished until Microsoft and Apple joined the party in this year, actually. Windows 10 Creators Update brought us Microsoft Edge 40 with full WebRTC support. By the way, I don't know the official good naming for Microsoft Edge, because if you select help about from Microsoft Edge, it will state that like version 40. But developers, they like to reference it by HTML engine, and it was version 15. So it's 40 or 15, they was the same. 1 month and a half ago, Apple finally brought its operating system update with Safari 11, and Safari 11 also featured a full WebRTC support, or not full. So right now we have 4 web browsers. All of them declare that they have WebRTC support, and we as developers can use them for video, that's title of my talk, audio, and data communications. Are they equal? Actually, they are not. First of all, by unknown reason, Apple Safari web browser, it supports only H.264 video codec. So all these bright Google dreams about using free license, free VP8 and VP9, none of them, sorry. If we want to video call Safari, we need to use H.264 video codec, which is proprietary, licensed, and lots of tricky details about it. Of course, WebRTC will select the codec automatically, but still. Next, screen sharing and ability to send video not from your web camera, but from a part of your page. It's only in Chrome and Firefox. Not supported yet in Microsoft Edge, not supported yet in Apple Safari. So, if you want to start a screen sharing from Chrome to Edge, it will work. From Edge perspective, it will be like a normal video call with one video stream. But if you want to do a screen share from Edge to Chrome, sorry, no JavaScript API available yet. And another unknown reason, somehow Microsoft Edge right now, it lacks data channel. So it can perfectly do video call, audio call, but no data transfer. WebRTC, data transfer, all these real-time things. Of course, we can do legacy WebSockets and so on, but main idea of WebRTC to provide real-time communications for all available data with amazing Google lightsaber demo where you control a virtual lightsaber with your smartphone and your gyroscope information sent peer-to-peer to your web browser in real time. Sorry, this demo will not work in Microsoft Edge right now. And there are small details, really small details, lots of them, small differences, countless. For example, it is H.264 UC video codec available in Microsoft Edge only. It's here for compatibility with Skype. It is turn over stun in Microsoft Edge, so we have little problems doing cross-browser source code, trickle ICE technology, but for this talk I want to focus on SDP differences because they are about video, and video is like a cornerstone of my talk today. About SDP. WebRTC, as I previously mentioned, it's all about peer-to-peer communication from one device, preferably web browser, to other device, preferably second web browser. WebRTC JavaScript API, it doesn't even have a connect API. No connections. It's offer API. You just wants to start a video call, and instead of calling connect, you call create offer. Next, WebRTC examines your network configuration, like what is your IP address, what ports it can open. You supply external service, and WebRTC, it query them like, hello, WebStan server, what is my IP address? And what ports I can use. It gathers all this information. You supply turn service for fallback if peer-to-peer is not possible. And after that, after some time, WebRTC gives you back a text packet, which is in SDP format. It's session description protocol. It's from Telecom. Very sad story. Developer need to take this packet and somehow give it to WebRTC on second browser. That's called signaling, and surprisingly, it's outside of WebRTC scope. It's like, okay, you are developers, you need to put out your own servers, like in Microsoft Azure, you need to somehow connect them, for example, with WebSockets, and you need to exchange all these SDP text packets. So WebRTC on browser 1 can detect network configuration. WebRTC on browser 2 can create answer for this offer. And after exchanging this text information, they will eventually connect to each other or fail to connect. It depends. Biggest problem about SDP text information is the fact that SDP contains two different pieces of information. First, it's network configuration, like IP address, ports, external IP address. Second, it's information about what media stream should be sent. Like I want to send video from my camera, audio from my microphone, and screen sharing information. These two things are different, and they are really bad if we want to implement solutions that want to send multiple streams. For example, if we want to start an audio call from one browser to another, and during that call, user like, I want video, and triggers button. From developer point of view, we want just to capture video from web camera and send it over existing network connection. But from WebRTC point of view, it will be completely different SDP packet with different network configuration, second one, and different stream configuration, and it's now for the goodwill of browser developers. If they can reuse existing network connection, okay. If they fail, WebRTC will start to negotiate all this network connectivity once more, and by triggering on video, user will happily encounter like a few seconds delay, and audio will stop sending, and it's not best user experience, really. So all of this requires browsers to send multiple streams of the SDP, and original SDP, Telecom one, it is very old, like older than 20 years ago. 20 years ago, it was no screen sharing, no multiple video streams with different resolutions. It was simple audio calls with video, sometimes, very rarely. And original SDP is dedicated to one stream. But browsers, even in simple configuration, they want free streams like video, audio, data maybe, and they want multiple streams for video and screen sharing. So SDP configuration, it was extended. And different browsers extend it differently. Chrome, Safari, and Edge, they goes with Plan B SDP extension, and Firefox, they are different. They use Unified Plan SDP. For simple calls, one video, one audio, one data channel, Plan B, and Unified Plan looks absolutely the same text packet, so you can do video call from Chrome to Edge without any problems. But if you want video and screen sharing, you will have problems. Of course, all these differences in web browser implementations, they are fixed by developers. Developers are trying really hard to fix it. So it's very good adapter.js library that unifies the differences. It provides API like in the latest version of working draft, and it try really hard to translate all these text SDPs between Chrome, Firefox, Edge, and so on. Unfortunately, working draft is full of surprises. And next surprise is no more SDP for us. Right now, WebRTC that's implemented in browsers, it's 1.0. It's called stable, and right now it's process of stabilization. But working group that works hard to create this specification, it's actually split in two. And second half, it works on WebRTC unstable. It's called WebRTC 1.1 or Object RTC. And surprise, surprise, Microsoft Edge right now is the only web browser that implements Object RTC. With Object ITC, it's no more SDP, no more text information, no more legacy. It's just JavaScript objects. And software developer, they can take object for network configuration, get fields, send to second browser. Then, after network connection is established, developer takes second object, like for video, get information, JSON it, for example, send over network to second browser, and ta-da, we have video connection, second video connection, audio connection over existing network configuration. They are now separate. And all of this is available in Microsoft Edge only. Also, for the sake of developers who used WebRTC for a number of years, Microsoft Edge implements legacy WebRTC 1.0 API, so developers can use existing source code, and so they are not forced to use adapter.js. And all these differences, how usable all of this. We are into communications and calls from web browsers for as long as WebRTC is on the market, and a few years longer. So from my experience during past few years, I can tell the story about how to do calls safe way. Actually, everything works just fine for all four major browsers for simple calls. And what are simple calls? First, most importantly, no switching streams on and off. If you try to initiate audio call and then you try to enable video with WebRTC, anything can happen. It can enable perfectly fine, or it can enable after a few seconds delay, or entire network connection can fail, or browser can crash on our end. Sometimes that happens, yes. So safe way is to always send all data you need, like audio and video, and if you want to enable, disable something on the switch of the button, you just enable and disable in the user interface, like hide video, detach video, audio from speaker, but still send it over network. No screen sharing, because screen sharing it's not supported by half of web browsers. And second, if you try to do screen sharing with video call, it's second stream, and difference between plan B and unified plan kicks in, so we will have problems. And no additional advanced things like simulcast, that's sending multiple qualities video with one stream if we want cross-browser support. This will work if we call from Chrome to Chrome, from Microsoft Edge to Microsoft Edge with Object RTC API. But if we try to call from like Chrome to Firefox, translate between plan B and unified plan, okay, sometimes it will work, but most of the times it will fail in some unpredictable way. And one of the amazing features about WebRTC, it's not only for browsers. As I mentioned before, Chrome, Firefox, and even Safari implementation, they are all based on Google libWebRTC. Of course, Firefox and Safari, they use only network and codecs layer with all JavaScript API, logic implemented by developers, but still library itself is highly tested, cross-platform, portable. You can compile it for Raspberry Pi, or you can compile it on Android and iOS. Lots of our clients, they create mobile applications with SDKs, and from this mobile application they can call to web browsers, cell phone numbers, and so on. That's really amazing connectivity between devices. And you see, then you stream video between two applications peer-to-peer, and on the conference, for example, all these devices, they are connected over same Wi-Fi. It's really good video quality without any pressure to company servers. And in order not to put on all eggs in one basket, it's alternative Open WebRTC library available. It's fully functional, just not use it anywhere, but it does exist, and anyone can use that alternative solution. WebRTC technology, it biased a bit, and during this talk I want to spend a little amount of time to highlight these biases again. They are highlighted during multiple blog posts and talks, but still WebRTC it's often marketed as a secure solution with good security, and indeed WebRTC encrypts video, audio, and data. But key point, this encryption, it's not automagical like with HTTPS. It's not depends on some keys built in operating system. This encryption, it uses keys that are taken from one browser DTLS handshake and transferred to other browsers, or a developer can supply their own keys. So WebRTC is as secure as developer who implements it. If developer fails to communicate keys safe way, sorry, WebRTC will be completely unsecure. Second, WebRTC, it's a lot of talks about peer-to-peer. You see peer-to-peer connection, Wi-Fi, direct connection, amazing video quality, but majority of calls, they will not be with us communicating on same conference, connected with same Wi-Fi. If we are in same room, we can communicate in person. So majority of calls, they are over internet, and on the internet rules are kind different, because internet service providers, they are tricky. They know that most of web browsers, they request services from big clouds like Microsoft Azure. So providers, they just optimize routes to Microsoft Azure. And if two persons, they happen to video call each other with WebRTC, direct connection between them can be much slower compared to connection from third-party server, which is in Microsoft Azure, because all ISP like Microsoft Azure and Google Cloud and Amazon Web Services, big things. And third thing, WebRTC, it's always referred as peer-to-peer. Yes, peer-to-peer is good, no pressure to your server, you don't need servers, and so on. Actually, WebRTC, it's not peer-to-peer like torrent. It requires manual signaling by developer. Developer need to take offer from one browser, somehow give it to second browser, take answer, give it to first browser, take ICE candidate, give it to second browser, and so on and so on. All of this developer need to implement it by hand. But still, WebRTC is really amazing technology, because right now it allows us developers to create cross-platform web and mobile solutions like Skype for web. It was impossible 5 years ago. Numerous educational solutions, telemedicines, real-time sensors, not for Edge right now, but I think it will change in the future. Interactive video streaming and much, much more. And for lazy developers or companies who just want to use all these advanced features without writing lots of code, there are always independent vendors like Twilio, Voximplant I'm working for. We provide ready-made SDKs for all web browsers, for mobile platforms. We provide our own cloud that can do signaling, that can do relay, and all developers need is like login, connect, video call. Everything just work. Later today, I will provide a 2 hours workshop. Then I will show how Microsoft Edge can be used alongside Notepad without any magic. So no third-party libraries, no signaling, no anything. We will just use a Notepad, Edge, and we will do a video call from one browser to other. I'll show some advanced tricks and answer any questions in person. So you're welcome to join me at a workshop. It have limited amount of seats available, so please come early. And right now, feel free to ask me anything on Twitter or right now. That's all. Your questions, please. We don't have second microphones, so I will just repeat them for the record and answer. Please. Interesting question. Actually, exchanging keys is part of SDP. This magic text SDP packet, it contains network-related information. And network-related information is a huge amount of data. Not only IP addresses and ports, but also keys for DTLS handshake. Developer can override these keys, or if they just send packet as is, this information can be exchanged and used by WebRTC. It's always encrypted, no way to disable encryption for WebRTC. Please, more questions?
Are there any plans to standardize the signaling? Because I'm surprised that's not part of the WebRTC.
Another good question, how to add signaling to WebRTC. Actually, no information available because it will be very tricky to add signaling into WebRTC specification. Some protocols like SIP over WebSockets, for example, can be added to working draft, but it will be kind of pointless because signaling itself is very simple. First, browser returns you some information. You somehow transfer this information to other browser and gives it back. How it is transferred, it's completely on developer. And no one will implement a free signaling service because signaling includes fallback relay. Around 20% of voice and video calls fail to do peer-to-peer connectivity, and such calls, if we want to establish them, we need to provide WebRTC with IP address, login, and password for some server on the internet that will pass through all these gigabytes and terabytes of video and audio data. So actually no one wants to do anything with signaling. More questions, please? Yes?
You talked about servers. Who owns those servers?
Another very interesting questions. Who owns servers? WebRTC, it relies on two kind of servers. First, very simple stan servers. They answer one very simple question: what is my IP address? Like WebRTC sends UDP packet to stan server, what is my IP address? And stan server sends one packet back, like your IP address this and port this, and we predict you not to be next port this. Such servers, they are freely available from Google, for example, and if you join my workshop, I will show how they are used, because it's very little amount of load on stan servers. And with turn servers, it's completely different story. Turn servers are for traffic. For 20% of cases where WebRTC fails to establish peer-to-peer connectivity, and such service, each company needs to put its own service. Yes, and we have servers all over the world, so our clients can experience flawless peer-to-peer connectivity. Microsoft, they have a DEMA server that I will use during my workshop. It was mentioned in tutorials like address, login, and password, something with Redmond. But of course, it's very slow test server, and if you try to put a real load on it, no one allows it. Any more questions? Okay, so thank you for listening, and if you want to join my workshop later, you're welcome.